final exam part 2 multiple choice. Number 1. What is the value of norm of w minus 4y, where norm of u 1, w dot u 5, norm of w 6? We are asked to evaluate w minus 4u. Given the most important property here, that's very important property, norm of u square means u dot u. So apply this property for the claim. Norm of w minus 4u square means w minus 4u dot w minus 4u. Dot product distribute over addition. So w dot w minus 8u dot w plus 16u dot u. W dot w, we apply this property repeatedly. So magnitude of u or norm of u square minus 8 times u dot w, that is 5 times 5 plus 16 times norm of u square. Norm of w, 6 square minus 40 plus 16 times norm of u, 1 square 1, that is 16. So 36 minus 40 plus 16. 12, that's the square, implies norm of w minus 4u is equal to square root of 12. 4 times 3, 2 square root of 3. That's the answer. So the answer is B, number 2. Which one of the following the value of alpha if vectors 2, 1, minus 1, 0, 1, 1 and alpha minus 1, 1 are linearly dependent? If three vectors are linearly dependent, one can be written as a linear combination of these two. So let's take the vectors, the three vectors 2, 1, minus 1, 0, 1, 1 and alpha minus 1, 1. Now let's take this vector and write this vector as a linear combination of these two because they are linearly dependent. So if they are linearly dependent, one written as a scalar multiple of the other. Therefore, alpha minus 1, 1 is equal to a times 2, 1, minus 1 plus b times 0, 1, 1. So for what value of alpha? So from vector scalar multiplication and vector addition, this can be written as 2 times a plus b minus a plus b. The two vectors are equal. From equality of vectors, alpha is equal to a plus b is equal to minus 1, and minus a plus b is equal to 1. Now add downward. 2b is equal to 0. This implies b is equal to 0. So if b is 0, what will be a? A is equal to minus 1. If a is minus 1, alpha will be minus 2. The answer is minus 2. Okay, question number 3 says f derivative at x is equal to g of x. G derivative at x is equal to f of x squared. F of 64 is 1. G of 8 is equal to 3. And h of x is equal to f of x cubed. Then the value of the second derivative of h at 2. We have h of x here. H derivative at x, that is f derivative at x cubed times x cubed derivative 3x squared. What's f derivative at x? G of x. This is g of x cubed times 3x squared. Then the second derivative at x is equal to, apply product rule here. The derivative of the first one, g prime at x cubed times the inner function derivative 3x squared times the second function 3x squared plus the first function gx cubed times the derivative of the second function 3x squared derivative 6x. You are asked to evaluate the second derivative at 2. G derivative at 2 cubed 8 times 3 times 3 9 2 square 2 square. Now multiply this 3 times 4 times 3 times 4 12 times 12 144 plus g of 8 times 2 times 6 12 is equal to, now let's look what we have. G prime at x is f of x square. Therefore, g prime at 8 means f of 8 square 64 times 144 plus g of 8 is given here 3 times 12 plus 36. F of 64, that is 1. So 144 plus 36, that is 180. Question number 4. Which one of the following interval contains the solution of the equation f of x is equal to 0? The function is given by. To apply intermediate value theorem, remember the condition. On the closed interval, to apply intermediate value theorem, the function should be continuous on the interval. And for the case of the k value 0, the functional value f of x to be 0, we have to have the functional value of the two endpoints opposite. So let's check one by one. The first one, a, from 0 up to 1. From 0 up to 1, it doesn't include 1 here in this interval. So we have to consider what should be our closed interval here. Our closed interval should be from 0 up to some number from the left closer to 1 to be included under this function, to be continuous. So we'll take some value 0.99 something closed interval. Now the function is continuous here. So by taking much closer, if there is a difference, we need to check. Now what's f of 0? What's f of 0.99? In both cases, our functional value is positive 15 over 2 at 0, and at 0.99 almost 1. This value is negative 5 over 2 almost. Therefore, negative 5 over 2 plus 15 over 2. This one is greater 15 over 2. Therefore, it is again positive. So at both ends, we have positive value. We can't apply intermediate value theorem. Here, minus 1 up to 0. Both are under this interval. But what's f of minus 1? Minus minus plus 5 over 2 plus 15 over 2, that is 10 at this point. And f of 0, 15 over 2, both are positive. We can't apply. C, minus 3, minus 2, both are under the interval x less than 1. So for this interval, our function is this one. It's a polynomial function, it's continuous. So what's f of minus 3? Minus, it becomes positive. Therefore, total value is positive. Minus 2, this value becomes positive, total value becomes positive. But at the interval D, 2 up to infinity. 2 up to infinity, which is greater than 1. So we can make our interval 2 up to m, very large number m. Now what's f of 2? First check f of 2. 2 is here in this interval. Therefore, f of 2, 4 plus 2, 6 minus 12, minus 6. And obviously, a polynomial function, polynomial quadratic function with positive coefficient. Whenever x goes to infinity, the functional value goes to positive infinity. That indicates at some point we have f of m, which is a positive value greater than 0. It goes to infinity. Whenever m goes to infinity, f of m goes to infinity. Therefore, negative and positive, they are opposites. Therefore, under this interval, there exists x, an element of 2 up to infinity, such that f of x is equal to 0. So we have a solution for this equation. On the interval 2 up to infinity, the answer is D, not B. Question number 5. Let f of x be continuous for any real number. Then the value or values of beta should be. Look, this is polynomial function, so continuous everywhere on the given interval. X squared is polynomial function continuous everywhere on this interval. So the challenge will be at the point where it's split. Now, everywhere means it should be continuous at beta. So we need to start by assuming that it is continuous at beta. Therefore, if it is continuous at beta, what we have, remember, we need to have limit of f of x as x approach to beta from the left is equal to limit of f of x as x approach to beta from the right. X less than beta, x approach to beta from the left, x less than beta. Therefore, what's f of x? 4x plus 12. This implies, look, limit of f of x, 4x plus 12, as x approach to beta from the left is equal to limit of as x approach to beta from the right. What's f of x? X squared, because x is greater than beta. And polynomial function limits direct substitution. Therefore, it is for beta plus 12 is equal to beta squared. From this, we have polynomial beta squared minus 4 beta plus, no, minus 12 is equal to 0. The products minus 12, the sum minus 4, minus 6 and 2. So beta minus 6, beta plus 2 is equal to 0. So beta, the product to be 0, beta should be 6 or beta should be minus. Now minus 2 at A, 6 at C, the answer is D. Question number 6. Which one of the following is the derivative of the function f of x is equal to e the power of cos square x minus sin square x? Here is a very important point in this problem is to remember the identity, hyperbolic functions identity. Cos square x minus sin square x is equal to 1. So the function f of x simplified to the constant function. Therefore, f derivative at x is equal to 0. Number 7. Which one of the following is true about a function f of x? 5x raised to 4 minus x raised to 5. The graph of f is concave downward in 1 to infinity. To answer this one, first we need to determine what's f prime at x. That is 20x cubed minus 5x to the power of 4. Second derivative at x, 60x squared minus 20x cubed. When we factorize this one, 20x squared common, what remains? 3 minus x. So the sign is dependent on 3 minus x. So the sign of this one at 3 minus x, here positive, here negative. So the graph of f is concave downward from 3 up to infinity, not true. An inflection point 1, 4. The second derivative change its sign at 3. So 3 comma f of 3 is the inflection point. F is increasing in the interval. Again, we need to factorize the first derivative to get increasing, decreasing interval. Here 5x cubed is common. What remains? 4 minus x, 4 minus x. On the number 9, 5x cubed at 0, x minus 4 minus x at 4. So from 0 up to 4, so this is positive. This one is positive, so this is positive. 4 greater than 4, this is negative, this is positive. For x less than 0, this is positive, this is negative, so negative. So negative, positive, negative. So it's increasing on the interval 0 up to 4. The answer is C. What about D? F has local maximum value at x equal to 0. It changed the sign from negative to positive. So this is a local minimum. Question number 8. What's the value of alpha and beta respectively if the limit of the function here we have x squared plus 3 over x plus 1 minus alpha x plus beta is equal to 0 as x goes to infinity? What should be the value of alpha and beta? Look, as x goes to infinity, the limit exists. No? What do you perceive from this? As x goes to infinity, this goes to infinity, and this goes to infinity. Infinity minus infinity. So we need to rearrange this expression, and its limit is 0. So we can write this expression as, look, add this, take common denominator x plus 1. When the denominator x plus 1 as a common, x squared plus 3 minus alpha x plus beta, or take minus as a common, this will, we can make it this minus times x plus 1, common denominator x plus 1. Look, when we expand this one, we will have x squared minus alpha x squared plus, here 3, we have constant, here we have minus beta as a constant, minus alpha x times 1, minus alpha x minus beta x, minus, you have minus plus beta x minus beta plus 3, the 3 minus beta over x plus 1. Now the limits of rational function to exist, the numerator degree should be less than or equal to. If the limit is 0, the denominator degree should be greater than the degree of the numerator. So here we have the degree of the denominator is 1. So we have x squared. Therefore, the coefficient of x squared should be 0. That means 1 minus alpha should be 0. This implies alpha is equal to 1. And the coefficient of x again should be 0. That is beta minus alpha plus beta. This should be 0. This implies beta is equal to alpha. That is 1. So we have the answer 1, 1. This is the last multiple choice. In the next video, we will proceed to the workout problems. So to get the video, you need to subscribe the channel and click the notification button. You'll notified whenever I release the video immediately. Thank you for watching.